real life example of how we multiply matrices together. And it might actually make sense. So we have this problem here. We have 3 games during the football season. We have the first 3 games here. We had 320 adults at the first game, 150 adults at the 150 students at the first game. Adult tickets were $5 and student tickets were $2.50. How much money did you collect for ticket sales during game 1? How could we figure that out? Multiply what?
320 by 5 and
320 times 5
150 times 2.
and 150 times 250. And then what we need to, we add those together. You just multiplied matrices together. So it's not hard. It's not complicated. It does look a lot different than what you might imagine multiplying matrices looks like. Here's our first matrix, and we're going to multiply by this, our price matrix, which is our $5 and our $2.50. These are adults. These are students. Does it make sense to multiply the 150 and the 5 together?
No.
No, because one's adults and one's students. That doesn't make sense. So for game 1, how can we figure out how much money we're going to make for game 1? You guys literally did this without a matrix. And you can probably do all 3 of these games without a matrix pretty quickly. But what if this was the Braves game? And the Braves play 81 home games every single season. And how many different ticket prices do they have in that stadium?
A lot.
A lot. How many people are coming to one Braves game?
A
Like
lot.
42,000 people, right? So you don't want to do all of those by hand. So yes, you could do this by hand, but let's talk about how might I do this with a matrix. You're going to take this first row, game 1, and you're going to multiply it by the price. But you can't multiply the 320 and the 250 together. You got to multiply the 320 and the 5 together. You got to multiply the 150 and the 250 together. And there, first row, first column, first row, first column. It lined up. So that would be game 1. This would be game 1. Well, what about game 2? Well, we would do something very similar. 290 and 175. We'd multiply by the 5 and the 250 again. But what are we going to multiply? We're going to multiply the 290 and the 5 together. And we're going to multiply the 175 and the 250 together. That's game 2. We just figured out how much money we made in game 2. Well, what about game 3? Well, we can do the same thing. The 350 and the 220, we're going to multiply by the 5 and the 250. But does it matter which ones we multiply? Yes, and we also have to add them together. So 350 times 5 and 220 times 250. So we only had the price for one season. What if we had the same amount of people come to the same number of games, game 1, game 2, game 3, we sold the same amount of tickets, but maybe the price for 2024 is going to change? Could we also calculate how much money we're going to collect from ticket sales in 2024? Maybe this price was a 2023 price. What could we do? Well, we could just make another matrix here and put the 2024 price here and here, and then we could do the same thing for game 1, game 2, game 3 for year 2024. We could do 2025. We could just keep making more and more columns to our answer matrix. So maybe seeing this real life example, maybe it kind of makes sense why we multiply matrices the way we do. So let's take a few notes. To multiply matrices, the number of columns in the first matrix, has to match the number of rows in the second matrix. Because if they don't line up, you can't multiply. Well, let's go back and look at the example we just did. What if we had game 1, game 2, game 3? What if we had adults, students? What if I also had children? I say children, we're talking like preschool, right? Before they get into like school. Preschool children. And we know how many tickets we sold to preschool children. But I didn't tell you the price. Can you figure out how much money you made if we know how many preschool children bought tickets, but we don't know the price we sold those tickets at? You can't multiply those because now the number of columns, 1, 2, 3 columns, does not equal 2 rows. I would need an extra row, the price of a child ticket, in order to do that multiplication, in order to figure that out. So the number of columns has to equal the number of rows. And if the number of columns equals the number of rows, we can actually multiply them, and we can actually predict accurately the number of the rows and columns that the answer or resulting matrix is going to have. So our matrix A is M by N. M and N are just numbers that represent, they're letters that represent any number you want them to represent. That's matrix A. And then matrix B, which we're multiplying by, is N by P. Well, what do we know about the number of columns in A and the number of rows in B? It's kind of hard to see, right? Like which one of those is rows, which one's columns, all that stuff. Well, here's what you can do. We can put a box around the two in the middle. That's the number of columns from A and the number of rows from B. Are they equal? Yes, they're equal. So I could actually multiply these two matrices together. And what is the answer going to be? The answer is going to be what's left over. We're going to have M rows and P columns in our answer. M rows and P columns in our answer. So let's just talk about, is it possible to multiply these matrices together, number 1, 2, and 3? And if it is possible, what would the resulting matrix dimensions be? How many rows and how many columns? The easiest way to do this is look at the two in the middle. We're going to multiply E times F. I'm going to put a box around the two middle dimensions. Are those equal? Yes, those are equal. So can we actually multiply E times F this time? Yes, it is actually possible to multiply E and F together. And what would the result of our matrix be? It would be a 7 by 3 matrix. Our answer matrix would be a 7 by 3 matrix. Number 2, can we multiply E times F in number 2? No, we actually cannot multiply these together. The 6 and the 5 are not equal. So on a multiple choice test, you would just probably write not possible. But on a quiz or test that is not multiple choice, because at the moment your quiz next week is not multiple choice. It might change before next week, but the quiz I currently have typed up is not multiple choice and not possible. We get you half credit because the directions are going to say and explain why. If not possible, explain why. So what could we say here? How do we know this is not possible? The number of columns in E does not equal the number of columns, or the number of rows, I'm sorry, does not equal the number of rows in F. What if you just say, like, here's your explanation, not possible because they are not equal? That's not going to get you credit. I don't know what they is. I can't assume that what you mean by they is the number of columns in F and the number of rows in E or whatever you mean it to say. Do not use vague language if you have to explain something in math. They, it. That's not good.
Columns and rows in it.
The columns and rows are not equal. We got to be more specific. The columns of what? It's the columns in E. The columns in E do not equal the rows in F.
So they have to be like the ones like side by side.
The ones in the middle, yes, the ones in the middle here have to be equal. Number 3, can we multiply number 3 together? Yes, we can multiply number 3 together. How do I know I can multiply number 3 together? Because the number of the number of columns in E is equal to the number of rows in F. And what would the resulting matrix be? It would be the dimensions that are actually left over. It would be a 3 by 8 matrix. It would be a 3 by 8 matrix. By 8. All right, now let's actually, like, we did that real life example, but let's actually maybe multiply some matrices together. All right, so to find the individual elements of the product matrix, that's the answer. multiply the corresponding elements of each row by the corresponding elements of each column, and then add those together. Why don't we do that? Because you gotta multiply the adult ticket times the adult price, the child ticket times the child price, and then add those together. So in this case, we got 2, 3, 4, 5. We're gonna multiply that by -2, 1, -6, and 8. So we're gonna take this first row. This first row, if we were to use this kind of the same example, that represents game 1. The column represents adults and students. This first one might represent day 1 and day 2. Maybe the price changed from day 1 to day 2 or something. This row is gonna represent adults, and this row is gonna represent students. You can't multiply students and adults. You just can't. So when I multiply these together, I'm gonna multiply the row times the column. But I can't multiply certain things together. So in this case, we're gonna multiply the 2 and the -2. And we're gonna add to that the 3 and the -6. How did I know that went in the first row, first column of my answer matrix? Because I used the first row and I used the first column. So that's where it goes in the answer. Now I'm gonna use the first row and the second column. And guess that's where that's gonna go in our answer. It's gonna go in the first row and the second column. So for day 2, 2 times -2. I'm sorry, 2 times 1 for day 2, 2 times 1 for day 2, and 3 times 8. So we got our adults, this would be day 2. We got our adults, and we got our students. Day 2, for our adults. Now, for game 2 would be represented by the second row here. So we're gonna do the same thing we just did in the first row, but now we're gonna use the second row. So the 4, 5, we're gonna multiply the 4, 5 times the first column. What happened on day 1? Game 2, day 1. 4 times -8. I'm sorry, 4 times -2, which is -8. And then 5 times -6. 5 times -6. And then we're gonna multiply the 4 and the 5 by the 1 and the 8 and add them together. 4 times 1 and 5 times 8. You can take some time to add these in your calculator if you want. I'm just gonna go ahead and tell you what they equal. We get -4 plus -18, which is -22, for our first element in the first row, first column. 2 times 1 is 2, 3 times 8 is 24. We add 2 and 24, we get 26. 4 and -2 is -8. 5 times -6 is -30. -8 and -30 is -38. 4 times 1 is 4. 5 times 8 is 40. 4 plus 40 is 44. So what would my answer matrix represent if we were using the same scenario? The rows represent the days, and the rows represent the games, and the columns represent the days. So we know how much money we made on game 1, day 1. We know how much money we made for game 2, day 2. And I know that doesn't really make sense in context because we're using negative numbers and stuff, but just trying to show why we multiply that way. All right, so using the given matrices, perform the indicated operation. Number 4, we want to do A times B. Before I even multiply, I want to make sure it's possible to multiply. A times B is a 2 by 2 matrix. B is a 2 by 3 matrix. The number of columns in A is equal to the number of rows in B. So we can actually multiply these together, and A times B is going to be a 2 by 3 matrix. A times B is going to be a 2 by 3 matrix. Now, how might we multiply A times B? Well, let's try. First row, first column. 3 times -3 is -9. Plus 4 times -1 is -4. So you can think about that as like the adult plus the children. Can't multiply the adults and children together. Now we're going to do the second day. 3 times negative 4 is negative 12, plus the 4 and the negative 2 is negative 8. So negative 12 plus negative 8. Now we're gonna do the same row, same game, times the third column, which represents the third day, if we're using that same scenario. So 3 times negative 5 is negative 15, plus 4 times negative 3 is negative 12. And that would be it for the first row. We've multiplied by the first row by all 3 columns. Now we have to do the second row. Do the second row. So the 5 and the 6. 5 times negative 3 is negative 15. 6 times negative 1 is negative 6. So we have the adult ticket plus the child ticket. We're adding those together, or the revenue. The adult revenue plus the child revenue. We're gonna do the second day, or the second column. 5 times negative 4 is negative 20. 6 times negative 2 is negative 12. And then we're gonna do the third column. 5 times negative 5 is negative 25. And 6 times negative 3 is negative 18. And now we can just add these together. Use a calculator for today if you want. Your calculator on your quiz, the first part, cannot have matrix capabilities, meaning you can't type this in exactly like it looks and just get the answer back out. There are lots of things online, websites that do that for us. The first part of your quiz, you won't be allowed to use that. The second part of your quiz, you will be allowed to use that. Negative 9 and negative 4, negative 13. We get negative 20, negative 27, negative 21, negative 20 and negative 12 is negative 32, negative 25 and negative 18 is negative 43. And then just to make sure we can identify elements in a matrix, what is the element in position 2, 3? A, B, 2, 3. So you got to multiply first. And then what is the element in the second row, third column? That would be negative 43. Negative 43. Number 5, DA. DA and AD are not equal. DA and AD will not be equal. So keep that in mind. Number 5 is asking for DA. DA does not equal AD. You know, like Mr. Washington, everything you've told me, everything I've learned says multiplication is commutative. I can multiply in any order we want. 4 times 3 and 3 times 4, always going to be the same thing. That's right. But not matrices, okay? If we change the order that we multiply matrices in, we will not get the same answer like 99% of the time. There are some rare occurrences that they do end up being equal, but typically they're not going to be the same. So when I find DA, I actually maybe want to write D over again and write A over again, where I don't make the mistake of actually like A's on the left, right? And D's on the right. I don't actually make the mistake of doing A times D, because A times D and D times A are not the same thing. So if you tried to work ahead, that's okay, but A times D and D times A are not equal. So maybe just write D on the left and A on the right so we don't make that mistake. We got a 2 by 2 matrix. We got a 2 by 2 matrix. Yes, they can be multiplied, and the answer is going to be a 2 by 2 matrix, because the 2 by 2 is left over. How do we multiply? 3 times 3, 6 times 5, and then we're going to add those together. So 3 times 3 is 9, and 6 times 5 is 30. And then we're going to multiply 3 times 4. 3 times 4 is 12, and 6 times 6 is 36.
So the right number always goes to the bottom number?
Yeah, that's correct. All right, so we did the first row. Now we're going to do the second row. We're going to multiply the 9 times the 3, which is 27. We're going to add to that the 12 times the 5, which is 60. So that was the first column, and then we're gonna do the second column. 9 times 4 is 36, and we're gonna add to that 9 times, not 9, I'm sorry, 12 times 6, which is 72. 12 times 6, which is 72. 9 plus 30 is 39. 12 and 36 is 48. 27 is 60, it's 87. 36 and 72 is 108. And can we identify the element in position 1, 2?
48.
That would be the first row, second column, that is 48. If we were to put that in context, it might say something like, how much did we collect? How much money did we collect from ticket sales from game 1 on day 2? That would be represented by game 1, day 2, if we use that example. All right, these next couple, I'm actually not going to multiply them out, but just to really emphasize that D times B and B times D are not the same, I'm just going to look at the dimensions. I'm not actually going to do the multiplication unless you just really need me to. But if we look at the dimensions of D, the dimensions of D is a 2 by 2 matrix, and the dimensions of B is a 2 by 3 matrix. Can we multiply D times B? Yeah, we can actually multiply that. And what's the answer going to be? What are the dimensions? It's going to be a 2 by 3. If D times B and B times D were equal, don't you think we would get the same thing in number 7? Let's see what happens with number 7. B is a 2 by 3 matrix. D is a 2 by 2 matrix.
Not possible.
Number 7 is actually not possible. So how can we say something that's possible and gives us a 2 by 3 matrix in number 6 is equal to something that's not possible in number 7? We can't. So here's what we can say. We can definitively say that matrix multiplication is not commutative. There might be an N in there somewhere. Commutative, maybe, I don't know. Commutative. I don't know. You get the idea. So it's not. I'm not actually going to multiply those together unless you just really need to see me multiply them together in just a second. Number 8 and number 9. Questions like number 8 and number 9. I would check the dimensions first and make sure that we can actually do them before I try to do all of the work. Okay, I don't want to do all the work in number 8 and get down to the bottom and be like, oh, I did D times B, I multiplied it by 1/3. Maybe I did A times B, but then I can't subtract them, right? So I'm going to look at number 9, and we're going to look at the dimensions to see if it's actually possible to do all of number 9. So D, the dimensions of matrix D. D is a 2 by 2 matrix. A is a 2 by 2 matrix. So if we multiply D times A, we get a 2 by 2 matrix. And then we're trying to add that to D times B. D is a 2 by 2 matrix. B is a 2 by 3 matrix. We can multiply D times B because the rows, the columns and the rows are equal. And we end up with a 2 by 3 matrix. Can we add a 2 by 2 matrix and a 2 by 3 matrix together?
No.
No, we cannot add 2 by 2 and 2 by 3. So number 9 is actually not possible. In number 8, what you need to do first in number 8, you need to do the DB first. Do the DB first, get that answer, and then multiply it by 1/3 on the outside. And then you're also going to do the AB, and then subtract. You want to subtract last. I'm not actually going to work that one out right now, but if you need me to, I will.